Hello, good afternoon, and welcome to Live from NOIRLab at Kitt Peak. I am your host, Rob Sparks, with our moderator, Jamaica Marshall. Our guest today is Dr. Tod Lauer of NOIRLab in Tucson, and he's going to describe his work on a very interesting observation involving a New Horizons spacecraft. Remember, if you have any questions or comments, you can enter them in the chat box, and we will relay them to Tod. First, I'd like to tell you a little about Kitt Peak, funded by the National Science Foundation and a NOIRLab facility. It was founded in 1958 and is located about 55 miles southwest of Tucson on land leased from the Tohono O'odham Nation. We are indebted to them for letting us use one of their sacred mountains for astronomical research. Kitt Peak is home to over 24 optical telescopes and 2 radio telescopes. Recently, NOIRLab, we always like giving you a little science highlight. And recently, NOIRLab had an image release of the irregular galaxy IC10 taken from the Mayo telescope on Kitt Peak. IC10 lies around 2 million light years from Earth in the direction of the constellation Cassiopeia. It is a starburst galaxy. Starburst galaxies, as the name suggests, are galaxies undergoing a fierce burst of star formations, one of my favorite types of galaxies. These galaxies are replete with incandescent young stars formed by gigantic clouds of cold hydrogen gas condensed and reach pressures necessary to ignite nuclear fusion. The luminosity of these newly formed stars is what makes the bright tendrils in this portrait of IC10 so vivid. The galaxy also abounds with one of my favorite types of stars, Wolf-Rayet stars, a rare class of star with extremely high surface temperatures. The surface of these stars can reach about 200,000 degrees, 30 times hotter than the sun. Okay, now we have our beginning out of the way. We can meet our speaker for the day. I'm going to turn over to Dr. Tod Lauer of NOIRLab in Tucson. He's had a long career as an extragalactic scientist, but recently has actually gotten into planetary science, which I think is a fascinating turn for him, for his career there. So I'd love to hear about this observation, how you got involved with it, Tod. So take it away.
Thank you very much, Rob. And I'm going to share my screen a little here and get a little PowerPoint going. Goody. Okay, so let's bring up the title, which is Moving the Stars with New Horizons. So this is an artist's concept of the New Horizons mission. And we never got that close to Pluto, but there you are flying over Pluto with its big moon Charon in the background. New Horizons was a mission to go explore Pluto and something in the Kuiper Belt beyond. It was launched, it's a NASA mission. It was launched in 2006 from Cape Canaveral, and that's the spacecraft being prepared for launch at Cape Canaveral. We like to say it's about the size of a grand piano, although one without a bench perhaps, and wrapped in what looks like gold foil, but it's really sort of aluminized mylar. And there's our high gain antenna to get the data back on top. And a very small spacecraft, but was launched at incredibly high velocity out of Cape Canaveral. Be able to get to the moon in 8 hours is the fastest thing ever launched from Earth. Was sent on to Jupiter, where it got a slingshot to make it go even faster and to direct it to Pluto. And then it cruised for several years. It went by Pluto in 2015 and then on to the Kuiper Belt object Arrokoth last year in 2019. So it's had 3 encounters, Jupiter, Pluto, and Arrokoth. I'm not going to talk about Pluto at length, although I'm glad to take questions on it. There is the business end of the spacecraft, and the opposite side you saw, that's an RTG filled with plutonium-238, enough to power it for 50 years. So that's how we're able to work out in the outer reach of the solar system, where the sun is incredibly weak, only about 1/4000th as bright as it is around the Earth. There is an immense team of people behind the mission. This is the science team. It's run out of Johns Hopkins University's Applied Physics Laboratory in Laurel, Maryland. That's a suburb of Washington, D.C. And it's kind of ballpark halfway between Washington and Baltimore. And this is a science team. And the PI, principal investigator, is Alan Stern, who is the third one from the left in the middle there. And there with him is Hal Weaver, who's the project scientist. And then our incredible Alice Bowman, who we call the mom, that stands for Mission Operation Manager. And she's sort of the Scotty of the mission. She knows every little bit of the spacecraft and how it works, and she leads the teams of engineers that actually maintain the spacecraft. And then, of course, you have to have a good project manager, and that's Glenn Fountain on the end there. And then 100 of us piled in behind there, and then there's even more engineers scattered around the world to support the mission. It was a very large-scale enterprise. So we went to Pluto in 2015. We picked up Arakoth, which was a Kuiper Belt object discovered only in 2014. We looked for an object to go to after Pluto, and we were able to discover one. Its original designation was 2014 MU69, which those of you familiar with asteroids recognize that as a discovery designation. And so we went past there on New Year's of last year. This is an image of Pluto we produced on the way in. It's not the best we had, but it gives a realistic look at Pluto. It's about half the size of the moon. We're looking right into Pluto's heart, as we call it there, Sputnik Planitia, which is a frozen sea of nitrogen that slowly churns over the eons. And Charon, which is fully half the size of Pluto, it's really a double planet. I always think that it makes me think of a cracked egg, but it's a body of mainly water ice. It's frozen and expanded, and as it did, the surface cracked. And the little red pole, which is where it picks up material from Pluto. The atmosphere, Pluto has an atmosphere, and it diffuses away, and Charon picks up a little bit of it like a cold trap. This is a picture looking into the icy sea, it's Sputnik Planitia. This is a terrain, there's nothing like it I've seen anywhere else in the solar system. It's these huge polygons 60 kilometers across where the sea slowly upwells and convects over thousands of years, and the sun erodes pits in it. The little thing below is a little image processing I did to bring out some of the textures on the surface. We have glaciers. We have basically all the geology on Pluto is frozen water, ice, and that makes the mountains and the crust. It's as hard as granite, so water plays the role of granite on Pluto. Nitrogen plays the role that water plays on the Earth. It's sort of cold, slushy, that makes glaciers that flow out into the sea, and you can see a glacier flowing out. We departed Pluto. It has an atmosphere. This is looking back, seeing the sunlight scattered into this ring around Pluto. And this is a picture that I put together. This is going further away from Pluto after the encounter, which was July 14th of 2015. You see Pluto lit up by the sun. That's sort of haze scattering the sunlight forward. Then there's Charon off to the side. It picks up a little crescent of sunlight, but if you look closer, you see it's glowing on the sort of upper right side, and that's Pluto shine. And the rest are stars, the endless stars of the Milky Way framing the backdrop. And to travel all this distance and see Pluto lighting up the dark hemisphere of another world is pretty weird. So here's my joke, and I won't read it. You can read it. And I just sort of summarize the encounter. We hadn't any idea very poor idea what Pluto looked like before it got there. And now there is an abundance of pictures and data, and we're still busy 5 years later trying to figure out what it all means. So I'm talking today about something a little different. It's not science, but it's a demonstration of the tremendous distance that we have traveled. As a kid growing up on Star Trek, I hate to say this, the original series when it was first shown, which is now a while ago, I was struck by the title sequence where the stars would drift by, the Enterprise, warp drive always going by so fast that, you would see the stars expanding around and blowing past the ship. And it was an incredible idea that if you traveled fast enough, you would see the stars move, or if you traveled far enough, you would see the stars move. And for our whole lives, the whole history of civilization, we have taken the stars as fixed in the sky, navigational beacons that you learn and can find out where you are on the earth, by looking at the familiar stars and knowing that they're in the right place and that they've stayed put there. And we even use them to navigate out to the moon and Apollo to get the attitude. How is the spacecraft pointing? Is it pointing in the right direction? Well, you look at the constellations. You had a little telescope on the Apollo command module to sight the stars. And so we've always taken this as the stars are part of the firmament. And if you go far enough, though, that's no longer true. And it occurred to us that going out past Pluto, past Arrow, now we're almost 50 times away from the sun as the size of the Earth's orbit, 50 AU. For those of you who are familiar with 1 AU is the size of the Earth's orbit, or the radius of the Earth's orbit, that we'd go far enough to actually see the stars move. And this effect is called parallax. And let's see if I can explain it. This little graphic is by a member of the New Horizons science team. To earn his keep, he plays guitar for Queen. You may know him as Brian May, but he also loves 3D imaging. And Brian put this figure together for us. The angles are grossly exaggerated here, but you start off from Earth, and there you see we go past Jupiter, past Pluto, out to the Kuiper Belt. And an object that is relatively close compared to the background stars. Well, you can see from the Earth, we have to look to that star to the right. From New Horizons, we got to look a little bit to the left. And so it appears to jump. And that's called parallax. And I'll show this again, a little more fanciful figure. This was a wonderful diagram prepared by Pete Marenfeld of NOIRLab. And again, the Earth's looking to the right at this star against a screen of background stars. New Horizons looking to the left. But look below. You can see the Earth view. That orangey star is kind of to the right side, as you expect, but with respect to the background. Down below, or with New Horizons view, it's a little bit to the left. And so the star has jumped between the vantage point. So we've known about this for over 150 years, that the close stars will move if you get far enough, if you change your vantage point. And in fact, it was really our first tool for mapping out anything past the solar system. How far away are the stars? And it was predicted that as the Earth rocked back and forth, going around the orbit of the sun, that the stars should rock back and forth in the sky. And you've done this probably lots of times yourself. You think about this. You're going to the airport and you're picking up an old friend who is across the way, say down maybe in picking up her bag or something like this, or luggage. And, is that them over there? And there's a big crowd, you can't get over there. So you shift back and forth in your feet, left and right, to get the people in the foreground out of the way. So we're used to that motion to bring out the distance to things and to realize the depth in the 3D world. So they looked for this, and they eventually found for a star called 61 Cygni, the constellation Cygnus. And they found it was a number of light years away. The Bessel did that, the astronomer named Bessel. And so parallax was observed. We observed it with lots of other stars, and we've used this to map out the nearby universe. And there is a probe called Gaia, which is doing this with very, very high precision, precise enough to get accurate distances for most of the size of our galaxy, and has revolutionized astronomy. So we have always done this, and has been an incredibly valuable tool to learn, our first steps of learning our way around the universe, how big it is, how far away things are. once you learn how far away the stars are, you learn how big the galaxy is, you're able to get distances to other galaxies, and away you go. But parallax is always difficult to show, and the reason is because the shifts are very, very small. In fact, if you take an image with a telescope, the star will make a blob, and the shift is typically smaller than the size of a blob. So it's hard to see. You can't really see it directly. You have to measure it and do analysis. And there's a couple other things that go on. First off, because we need to see it as the Earth goes around the sun back and forth and changes its perspective. Well, that's going to take 6 months to get to the other side of the orbit. But while that's happening, the star is going to have drifted in space. It's not going to stay put for us. Stars move, as they go around the galaxy. And so that's moved. And how much is parallax and how much is motion of the star? Well, then you wait for another 6 months to come back to where you saw before, so you can null out the motion. And the truth is, you take, really like a handful of years to make measurements. You get this little, wavy pattern on top of the star's drift, and you get parallaxes. But it's hard to show. And if you pick up any textbook on astronomy anywhere, you always see a diagram. You actually won't see the stars jumping because we just don't have images that show that, purely from parallax, and the jumps are very small. The New Horizons, though, we have a different matter. We have this immense baseline, not the size of the Earth orbit, but nearly 50 times as big. And this is the cool part, we can take pictures from New Horizons and the Earth at the exact same time. So the star hasn't moved an inch if you take them at exactly the right time. And so no motion of the stars, none of this waiting back and forth, and the shifts are gigantic. And so you should be able to see the stars jump. Now our telescope on New Horizons is small, it's only an 8-inch. The accuracy is actually low compared to Gaia, so this is not a scientific experiment, but just a fun way of showing how far we've traveled. We've traveled so far that the stars are jumping, they're moving, they're not where they're supposed to be. The sky is becoming alien as we leave the solar system and head out in the galaxy, and it'll only get worse for New Horizons. Things are changing from its perspective. But it's a fun thing to show. It's educational. I think it says, look what we're doing. We're heading out into the galaxy. The stars are moving. And it's a great demo for the textbooks because now we can give some real pictures of this happening. And I'm going to show you these in just a bit. So we picked 2 nearby stars. One is Proxima Centauri, which is the nearest star to us. I know past the sun, you always have to say that because people object. They say the sun's a star too. It's the nearest star past the sun. It's a red dwarf. Most of the stars around us are red dwarfs. They're very faint, but you can see this in a small amateur telescope. The green circle there is where it would appear to be from New Horizons. Proxima is right in the center. And we took a second star, again known to Star Trek fans, Wolf 359. But there is another little reason that we did this, is that with 2 stars measuring their jumps, we can actually figure out where the spacecraft is. We know where it is from the Deep Space Network, the high accuracy, but imagine you're there on the spacecraft by yourself, navigating start of an interstellar journey, and you had no contact with a catalog and a telescope. You can look at the stars moving and figure out how far you are from Earth and in what direction. And this is something completely new. For the whole history of civilization, we've navigated by assuming that the stars are fixed, whether you are on the ground, trekking across an unknown continent, as we did, hundreds of years ago, or you're a mariner at sea, a pilot in an aircraft, or an astronaut flying to the moon for the first time. The stars are fixed. Well, now on our interstellar journey, we navigate by how the stars move. And so this is fun. So let me show you what we saw for Proxima Centauri. And this has never been seen instantaneously before. This is the difference in perspective. We got amateur astronomers and other professional astronomers to take pictures on Earth. At the same time, we were taking the images on New Horizons, and you see it blinking back and forth. New Horizons, Earth. New Horizons, Earth. And by golly, there it jumps. And that is an immense, easily seen jump, considerably larger than what we measure from the Earth. In fact, what's fun about this is you can think of this as having two eyes spread apart by the width of the solar system, and the way your two eyes give you 3D perception. Another demonstration of parallax, we can make a 3D image from these, and that's what Brian May did, and I can't show you on YouTube. You need to get the things with a special viewer or cross your eyes, but they are available if you go to the New Horizons APL website. We offer real 3D images, and you will see Proxima Centauri floating against the more distant stars. And Wolf 359, it's further away from us than Proxima Centauri is. It's about the fifth closest star outside the solar system. Its parallax is half as big as Proxima's, but it jumps as well. And so two stars, two parallaxes. It shows how far New Horizons is from Earth. The stars are actually moving, and the parallaxes will get even bigger as it goes out in the galaxy. So that's my introduction, and I'm glad to take questions about this project or anything about New Horizons, or I don't know, anything else in your mind at all.
Thank you, Todd. I will kick things off with the question I've had, so I think might be interesting, is what telescopes were used on Earth to take the Earthbound images?
Right, and I'm gonna have to see how well I remember these. So you don't need a big telescope. Sort of a small amateur telescope can see Proxima, and Wolf 359, to see it just by eye, requires probably a 10-inch telescope. But of course, these days of amateur astronomy, you have CCD cameras. Everybody has cameras that you can put on and work with your laptop. Proxima Centauri, the image was obtained by the Las Cumbres Observatory. They operate a global network of telescopes of various sizes. We use their smallest size, if I remember, sort of a half-meter size telescope. And it was operated by Edward Gomez, who's one of the astronomers that works for Las Cumbres. And their particular telescope that they used was at the Sighting Spring Observatory near Canberra, Australia. For 359, we had, I can't remember his first name, astronomer Kielkopf at the University of Kentucky. And I'm embarrassed I did not refresh my memory as to his name, and his colleague that worked with him from Harvard. But they have a remote telescope on Mount Lemmon, just north of Tucson, again about the same size, and they operated from Kentucky to get the Wolf 359 image. But we did get images from all over the world, and we looked for the best ones to match to the New Horizons. And there was a little bit of image processing done to adjust the ground-based images to the same scale, rotation, orientation, and intensity. And that was work done by John Spencer on the New Horizons team. And just looking here at Proxima going back and forth, you can see he did an excellent job of getting the two images to match.
Thank you, Dr. Lauer. May I add some comments here, Rob, from our YouTube audience? Fantastic. So we have Liz Flemings from Memphis, Tennessee, joining us today. We also have Ariel Vallejos, as well as some colleagues from CTIO. Claudio, thank you for joining us. And several more guests, Leanne as well in the audience. So we have lots of people who are excited to hear about New Horizons. So first, Dr. Lauer, I'd like to, for those people who don't know about New Horizons, we know it was the first, our first mission to the Pluto system and the Kuiper Belt. For those of us who may not be as familiar with the Kuiper Belt, some of our audience, could you just give us a quick description of what the Kuiper Belt is?
Yeah, absolutely. So this is kind of fun, and it's something that, you know, only dawned on me how important the Kuiper Belt is. So as a kid growing up, you know, we had 9 planets. You had the rocky inner planets, you know, from Mercury out to Mars, include the Earth. Then you had the gas giants, and that's your Jupiter, Saturn, Uranus, and Neptune. And then Pluto was sort of this oddball all the way out. You're kind of like, well, what's that about? So 20 some years, or maybe now 25 years ago, astronomers found other planet-sized objects out about the same distance of Pluto or even beyond. And it became clear that this was a new third zone of the solar system. It's sort of like having a house that you've lived in your whole life, you know, and then wait a minute, you know, there's an extra floor to it. You didn't even know that there's a third floor in your house. You opened up this door that had been concealed, and so you got, and you know, and what's up here? Oh my gosh, there's an attic with all sorts of stuff in it. The Kuiper Belt is small icy bodies. There are a few objects about the size of Pluto, things that, you know, we might call planets, some a bit smaller. There's lots of very small icy bodies like Arrokoth that we went to with New Horizons and explored last year. But it is sort of the leftover debris from the formation of the solar system. The closest analogy is the asteroid belt. It's a flattened system, so we could call it a belt. It's in the plane of the solar system. It goes from Pluto's orbit, which is about 30 AU, out to 50 AU. That's most of it. So it's not, you know, incredibly concentrated. But at this count now, you know, we know, gosh, the count is 3,000 or 4,000 objects, and so now this is a rich new part of the solar system to explore. And what has really come out of this is, because this is the debris left over, you know, what the orbits are, what the compositions are, you know, what's scattered around. We have learned an awful lot about the formation of the solar system that we didn't know. And we're just starting to explore this. And so, you know, keep tuned over the next decades, and we're going to learn a lot more from the solar system as we explore this.
Thank you, Dr. Lauer. If I may continue, we have 2 questions. Our first question is from Liz Flemings from Memphis, Tennessee. And she asked, what has been the most intriguing information you've learned through the New Horizons mission so far?
Well, gosh, it's sort of like, you know, which of your children is your favorite? You know, it's Pluto was a essentially unknown world, and different people, you know, see different things. I mean, I would say one thing which was suspected before we went out to Pluto was that it would have an ocean of water underneath its crust, like we think Europa does, or Enceladus has, or Ceres now. And this has increasingly become a theme in the solar system, that, you know, the Earth's ocean is but one of many across the solar system. And we think that Pluto has an ocean of water underneath its icy crust. I think the diversity of Pluto is incredible. It has glaciers, it has mountains, we think it has volcanoes, it has an atmosphere, it has this churning sea of frozen nitrogen ice. And it's just an incredible richness. You know, I thought, oh, well, you know, it's going to be a cold, dead rock frosted with a little bit of junk on it. And it's actually an incredible world with a functioning geology. It's very slow because it's cold, but I think the diversity of phenomenon. Pluto is a full-fledged world with an immense amount of things going on. And that, I think, was a surprise for a lot of us.
Thank you, Dr. Lauer. Yes, I definitely remember too watching this and not having an idea really of what to expect and just being fascinated at what we were finding out from New Horizons about Pluto. So to continue that, because that was a fantastic explanation, we have, I believe this is Pabloster, and I apologize if I mispronounced that. Pabloster is asked, is it going to reach the Oort Cloud eventually? So here, thank you so much for that question. Could you give us a brief explanation of what the Oort Cloud is, and then follow up with the answer?
Sure. So the Oort Cloud, if you want, if the Kuiper Belt's the third zone of the solar system, the Oort Cloud is the fourth zone. And we know very little about it. It was a theoretical construct. The comets with the largest orbits seem to come in from all directions. A lot of the short period comets come into the plane of the solar system, so we know that they know about the other planets there's information there. But the ones that come from large distances come from a cloud. And Jan Oort, who was an astronomer, a prominent astronomer in the last century, hypothesized that there is a cloud of leftover debris out there that produces some of these comets. And in his honor, we call it the Oort Cloud. We have not been able to detect it directly. It is very far away. The objects are going to be extremely faint. But it is an unknown part, and this will be something astronomers of the future are going to try to crack. New Horizons is heading out to the galaxy, and so it'll blaze through it. It starts kind of several hundred astronomical units out, so we're not out there yet. But eventually, in the coming centuries, as New Horizons goes further and further away from home, it will go right through the Oort Cloud.
Thank you so much. That is exciting. And thank you for the explanation on the Oort Cloud too, because there are some people who may not have known what that was. And thank you again, Pabloster, for that question, spurring that discussion on the Oort Cloud.
I can't resist mentioning that I had the pleasure of meeting Oort himself once. He was born, I think, in the first decade of the 20th century, and I was a postdoc in the 80s. And he came to a lecture I was giving, and he sat there very politely in his late 80s, just taking notes, still doing astronomy. I regret that he passed on, I think, at the end of the 80s, but it was a delight to have met him, a wonderful person.
I bet it was, absolutely. Thank you so much for sharing that. I'd like to end our comments here with just a question about parallax. You were in your amazing images that you were sharing on the slides, you were using parallax, you referred to it. Could you explain what parallax is? And then I'll come back a little bit later with more comments and questions from the YouTube Live audience.
Sure. Well, parallax is a change of where you see something just by changing your position or changing your perspective. The way that everybody always asks to demonstrate it is, you hold your finger up in front of your eyes and you blink one eye and then the other, and by golly, your finger jumps between points in the background. I can remember when I was a kid and I discovered parallax, and it was a really bizarre experience. It's from the Midwest, and we were traveling through a cornfield, and way past the field, there was a relay antenna, a microwave relay antenna. They had those towers back then, this big tower with antennas on the top. And I was really unsettled because as the corn was whipping by, the roadside, and the rows were playing out, this antenna was staying right with us, and it looked like it was traveling through the corn. And that was because the antenna tower was far away, and so the angle wasn't changing much, whereas the things in my foreground were blazing past, but it was an incredibly compelling thing. I didn't understand what I was looking at. So, we use it all the time, to measure distances and things, triangulation, how far away is something? If you can't go to it, you look at one place, you look at another place, and the angle changes with respect to more distant reference. With us, stars the same way. They're the baseline, as it's called, is the Earth going around the sun, or as we've done now, in the New Horizons at the edge of the solar system, the Earth in the heart of it, different angles to something nearby, and that object looks in a different place with respect to things more distant.
Thank you. And if you're ready to proceed with your presentation, you may do so, and I will just collect the next few comments and questions for a little bit later.
Okay, well, I think that's Todd's last slide, so we're pretty much in discussion time right now, right?
Yep. That's all I got. I can
Okay.
I can give you a choice. I can put up my ugly mug, or I can keep Proxima Centauri blinking back and forth there.
Well, I've got a couple another thought on this. I'm just curious, Todd, or maybe there's more of a suggestion than a comment. I would love to see if you said New Horizons has fuel for about 50 years, and it's been about 15 years. I'd love to see this done again in another 20 years or so to see how much farther it's traveled at that point.
Yeah, I realized after I said that I may have exaggerated a little bit. I think that the question is, can we make it to 2040? So I think 30 years is more the time span, and we may make it out to 100 AU. That's kind of a goal. So we might get twice the distance. That will be a long time in the future, and as somebody, in my 60s living in the age of COVID, 2040 would be a nice ambition. The joke was when the engineer got up and, gave the last time the team got together, he said, well, I think I can, possibly guarantee the spacecraft getting out to 2040. I don't know about the science team. So, but we will see how we are. We have a finite amount of fuel on the spacecraft, and right now we are looking for another Kuiper Belt object to explore. The probability that we will find one is pretty low. We find lots of Kuiper Belts so we can image from a distance, but to change the trajectory to go explore one, it has to be right along where we're going, and we only have like a 1% chance that we'll find something. But we're looking right now, and if we do find one, it probably will make an encounter that will consume the rest of our fuel, and that would be the end of the mission. If we don't find something, then we have a little fuel to spend as you go out there. And there are other things to study, as I say, long distance observation of some of the other Kuiper Belt objects and all the rest. So the question really will be, will the mission still be operating, or will we have consumables, that we'll not spend on science before we get out there. So I think we that would be fun to try again, but only if we've exhausted everything else science-wise that we can do with our limited resources.
Are there any other questions, Jamika?
Yes, we do have more questions. Okay, so question here from Ariel Vallejos. Ariel asks, what is the farthest object from which we receive news from the probe?
Well, yeah, and New Horizons, as far as it is away, is just getting started. The record distance holders are or rather say distance record holders, are the Voyager spacecraft, Voyager 1 and 2, which were launched in 1977. Voyager 1 went to Jupiter and Saturn, and on the way out of Saturn got the first good look at Titan. And Voyager 2 followed the path of Voyager 1, but instead of going to Titan, it diverted at Saturn and went on to Uranus and Neptune. And they are now out at almost 130 AU, and we won't be able to follow New Horizons that far. It does not have enough plutonium and a powerful enough radio transmitter that we'll be able to pick it up that far. But we're still talking to the Voyagers, and I think it's possible that, you know, we still have, well, we'll probably lose them sometime in this decade, but, you know, we may make it, you know, for a few more years before we lose them. And so right now they have, and will have for a long time, the record as far as the spacecraft communicated with. I'd also maybe like, pardon me, I'd like to add, for those of you who are interested, there is a website called DSN Now, the Deep Space Network operated by NASA to communicate with all spacecraft away from the Earth environment. And at any given time, there's 3 sites, well, you can see what they're communicating to. There's 3 sites around the world. The DSN was used back in Apollo to get the video back from the moon. And you can see who they're talking to at any time. And you go there on any day, they are still talking to the Voyagers, and you can watch them playing the communications.
That is really interesting. In fact, I'm going to drop a link to the Deep Space Network in the YouTube chat right now. I just did. That is really awesome. Yes, so that we can actually see how this communication happens and what's going on. Thank you for that, Dr. Lauer. And we have another question. If we could continue here to wrap up. I'm really excited for the comments and questions we're getting from our YouTube audience. So thank you all so much, and please keep those going. Okay, so Mateo asks, is there any other proposed project for EHT? Now, I know that's you know, a different mission than New Horizons, but if you could maybe give us a quick explanation of what EHT is, the Event Horizon Telescope, maybe a little bit about that. And if you know if there's a new project with EHT, we'd appreciate that. And if not, that's okay too. But a little bit of background, I think, would be helpful for our audience. And thank you, Mateo, for the question.
So for me, that's a very amusing question, because the joke is I have 2 Horizons project. I am a member of the New Horizons team, and I happen to be a member of the EHT time, which is Event Horizons Telescope. And you know, my interest, technical interest, why I'm part of both, is to help with the image processing. And the purpose of the Event Horizon Telescope was to link telescopes, radio telescopes, all over the Earth to get the highest resolution. That's called an interferometer when you combine 2 antennas very far away, to get the best resolution of a black hole at the center of a galaxy. And right now we can actually resolve information around the event horizon, or Schwarzschild Radius as it's called, of 2 black holes. The black hole in the center of our own galaxy, we call that Sagittarius A star, and the black hole at the center of M87. M87 that's a Messier object. You can see the galaxy with a you know, reasonable amateur telescope. It is at the heart of the Virgo cluster of galaxies, so that's in the constellation of Virgo, and it's really the nearest good cluster of galaxies to us. And M87 is right in the center. It has this famed jet that comes out of it, which is powered by matter falling into the black hole. That's been known for a century. Even before we had the idea of black holes, we saw this jet. And last year, shortly after the Arrokoth encounter, we released images of the M87 black hole. And this had never been done before. And this showed the event horizon for the very first time, and it was exactly as Einstein predicted. And so we also have data on the Milky Way's black hole, and we do hope to release that sometime, and I don't know the time scale, but say ballpark within a year. And that has been challenging. As seen from the Earth, the Sagittarius A star is a little bit bigger than M87 in its apparent size. the black hole is 1,000 times smaller in mass. The black hole in our galaxy is about 4 million solar masses, where the black hole in M87 is 6 billion solar masses. So that's a bigger beast. The the way to say this is that the black hole in M87 is the size of the solar system. In fact, given how far Voyagers have traveled, that's just about the size of the M87 black hole, about 120 astronomical units. The black hole in our galaxy is about the size of the sun. That's a different matter. But because it's so much smaller in real physical size, things happen a lot faster. And one of the challenges is that, it doesn't, the plasma going into the black hole, which gives off the radio waves that we image, don't quite stay put. And, taking a snapshot of Sagittarius A star is like taking a portrait of a little kid that's squirming all over the place. And you say, well, we'll try another. Oh, no, that one came out blurred. Let's try another one. And so understanding how to get a good image out of a data set where the object that you're studying is changing over the several hours it takes to build up the data set is a challenge. And so hopefully we will crack that challenge and we'll have something to show in a year. But yeah, those are my two Horizons telescopes. Last year was kind of interesting being part of releases from the two separate projects, which really have nothing to do with each other. I joke that I'm the only one who's on both of them.
I did not know that you were part of the EHT team. So again, Mateo, great question, because it's just allowed us to find out even more interesting things about you, Dr. Lauer. And so if I could continue on with another question related to EHT, you mentioned the Schwarzschild Radius. Could you just briefly tell us what the Schwarzschild Radius is?
Right. So and
Furball, I do.
okay, this is another little sort of special story. Carl Schwarzschild
Sit on.
Somebody is chattering.
Oh, sorry.
Carl Schwarzschild was a German astronomer in the town of Göttingen, who was born in the 1800s, and he went off to fight in World War I. And sadly, he died during the war. But when he was in the trenches, he got Einstein's then brand spanking new theory of general relativity, which is how gravity works. And one of the things that he realized is that if you concentrate a small amount of matter or a large amount of matter in a small space, enough so to get extremely strong gravity, that the equations required a solution in which basically the object disappeared from the rest of the universe. And there is a scale at which this happens, which is called a horizon. And the horizon, in some sense, works a bit like a horizon at the ocean. That is, there's something beyond it, but you can't see past it. If you're standing there on the shore, you know that you can only see out so far. And after that, you have no vision of what's past that. And so it is with a black hole. They didn't call them black holes back then. That wasn't a coinage made till the 60s. And Carl Schwarzschild's solution was very theoretical. He did not discuss how you might make one of those or what other properties would it have. That fell to another physicist named Robert Oppenheimer, known as the leader of the Manhattan Project. But Carl Schwarzschild was the first one that showed that something unusual happens when you have high concentrations of mass in a small area. And for that, we named the horizon size the Schwarzschild Radius. And my story here is just I had contact with Jan Oort. His son, Martin Schwarzschild, who's one of the finest persons I've ever known, was the one who figured out the structure of stars, and then he worked on the structure of galaxies. He had a long career as an astronomer. He passed away in the 90s. When I was a postdoc, I had my office next door to his for 6 years, and he was a mentor to me. He was a wonderful person with immense curiosity and a great sense of humor and great wisdom. And it was a pleasure to have had that connection.
Amazing. Thank you so much, Dr. Lauer, for answering all of our questions and for your amazing insights. If anyone else in our YouTube audience have questions or comments, please go ahead and put them in the chat, and I will make sure that Dr. Lauer gets them and is able to respond a bit later. Thank you so much. Over to you, Rob.
I was gonna say, could I take us out with an amateur who actually made a similar observation to yours, Todd?
Absolutely.
That I showed you yesterday. I'm going to share the screen here in a moment because my friend Mike Wiesner, he's a retired engineer. He lives up near Oracle, just north of Tucson. You can see his little observatory right here. This is a post he did on June 12th. But on the same date that New Horizons took the images of Wolf 359, Mike did too. And he, of course, waited until New Horizons released those images. And then, of course, he went to the website, he grabbed those images, and he overlaid his images on them. And you can see at the bottom, his image versus Wolf 359 right there as it bounces back and forth. So even an amateur, I think he uses, I can't remember if it's a Meade 10 or 12-inch telescope, and he's a Nikon person. I can't remember what model of Nikon camera he uses, but that was taken with a DSLR on about a 10 or 12-inch telescope, which also clearly shows the parallax of Wolf 359. He did not do Alpha Centauri, of course, because Proxima Centauri, of course, because Proxima Centauri is south of the equator, so he could only do Wolf 359. But even amateur astronomers have managed to get their own images and put them with the New Horizons ones. So I think that's just fantastic that you inspired amateur astronomers to go out and try it as well.
I'd like to add, if I may, something I did forget to say, that the New Horizons images and the Earth images that we did use are available on the New Horizons website. And so we encourage people to go play with those if they like, and get them to match themselves. And any amateurs out there who did take data on those days are, again, go ahead and have fun making your own pairs with it.
Mm-hmm. Yes. I have an image from that day I haven't processed yet, so I won't.
Well, you better get to it. You better get to it.
I've been negligent. What can I say? So, anyway, thank you very much for joining us, Todd. Next week we have live from Gemini, correct, Jamika?
Yes. Next week, live from NOIRLab will be at Gemini, and our host will be Alyssa Leilani Grace, and I will be moderating.
And I believe it's on the recent Hawaiian named quasar, correct? That's what I saw in our information, if I remember correctly.
I believe you are correct, Rob.
Okay, so that's a great story and a great one to tune in for. So we hope you'll join us all next week. So thank you very much, Todd, and thank you, Jamika.
A pleasure. Thank you.
And we'll see you next week.